going to go ahead and have the opportunity to see it afterwards. So this is our second webinar. Again, we are going to be talking about key concepts today of G0 and Unit G1. Remember that G0 was a lot of the constructions that we had to do. It was a lot of the vocabulary that we talked about. And then it was a basic introduction of all the things that we looked at. Okay, so let's get started with some basic vocabulary words first that we're going to go through. This is a point. Remember, a point is a location in space. It's just a little dot, and we represent it with a capital letter. Okay, so we can say point A or point B. It doesn't matter the letter that we use. It's just always represented by a capital letter. Okay, so remember that. A line segment. Remember, the line segment is a small piece of an entire line. So if we were to have a line that goes like this, for example, a line segment, it could be from here to here. It's a small piece of the line that we are going to be looking at. The way that you denote it, remember, it has a beginning and it also has an ending to this. And we always use the two capital letters where this begins and this ends. Okay, so a line is represented with arrows, meaning it goes into the negative infinity, and then it goes to positive infinity, and it goes on forever and ever. And it just so happens that it passes through these 2 points called A and B. Any questions so far before I continue? Are we good? Okay, good. Thank you. I appreciate you guys being honest with me. So let me go back and let me continue. A right angle, remember, it has 90 degrees. We will be able to see the 90 degrees right here, and it's represented with a box. It's a triangle that we're talking about, and it's special triangle. It has a 90, 30, and 60 degrees. We have congruent line segments. I should have put line segments here. What a congruent line segment means that you have two lines that are basically equal. So if the distance from here to here is 10 units or 10 inches, so will be the second line. Like I said, I'm going over the vocabulary real quick so that you understand what it's expected for you to know for the fun. So congruent segments means lines that are the same. Remember, array is half of a line if you want to think about it, or array has a beginning but it has no ending, as you can see here. So it has a beginning and it has no ending. We always represent it with capital letters because we're talking about 2 points. So A will be located here, and for example B can be located here in this line segment, and it just goes on. It has a starting point and it has no ending. Remember, the arrows tells you it goes on to positive infinity, or it goes on until it reaches infinity or beyond, right? An angle, remember, an angle is basically a figure formed by two rays. Okay, remember what a ray is. It has a beginning and it has no ending, and the angle is always represented with this little mark here of half a circle, and it can be any degrees that you can think of. Okay, so a vertex, remember, is the beginning or the starting point of two rays. So it's this little dot right here. I'll put it in different colors so you guys can see. This one here, it's basically the beginning of ray 1. We'll call this ray 1, and we'll call this ray 2, as you can see. I'm trying to go through a little quick with the vocabulary so that I can jump into the good stuff. Remember, an acute angle is basically between 0 and 90 degrees. Let's see, an obtuse angle is between 90 degrees and 180 degrees. It's not exactly 90 degrees and it's not exactly 180. That's why we put the inequalities there of just less than. Okay. Supplementary angles means that you have two angles. We'll call this one angle 1, and this one will be angle 2, and you are basically adding angle 1 plus angle 2, and you set them equal to 180. It's really, really that simple when we talk about supplementary angles. And you should know this by now because even in Unit G2, we're still talking about that one, right? So be aware of that. Complementary angles, again, it's two angles. We'll call this one 1, we'll call this one 2, and we have the measurement of angle 1 plus the measurement of angle 2 that is equal to 90 degrees, okay? So that's the difference between the supplementary, as you see here, and a complementary. Let's continue. Parallel lines, lines that have the same slope. Okay, that's very important for you to know because we have been talking about this in this unit, that it has the same rise over run. If they're both positive, if the first one's positive and I say that the second one is parallel to it, that means that the second one is also positive. And I mean, it's really that simple. Perpendicular lines is basically lines that intersect, and when they intersect, they create 90 degrees. Okay. Before I continue, do we have any other questions so far? Any questions so far? Are we good? All right. Sounds good to me. Let's continue. So, adjacent angles or two angles. As you can see, we'll call this one 1, we'll call this one 2, and they are right next to each other. They share a vertices, as you can see here, and they have a common side, okay? So they share a vertices and then they have a common side. The side is this blue ray that you see here, and the vertices is basically where the ray begins and it hits this line. We'll call this one little l, okay? Line little l, and we'll call this one ray. We'll call this one A, B, so we'll call this one ray A, B. Okay? So that's where they meet. And so they're adjacent to each other. They're right next to each other, I should say. And they share a side and they have a common vertex. Vertical angles are angles that are opposite from one another. And we know that vertical angles are also congruent to one another. So that's something that you should know. Angle bisector means that if I have an angle here, and when I say bisects, it basically means it cuts it in half. So whatever the angle we have here, let's say is 90 degrees, it'll cut it in half into 45 degrees and then 45 degrees, for example. So just remember, it cuts it in half. In half. Triangle, it's a polygon with 3 sides, remember that? We can still call it a polygon because it has sides to it. It's just 3 sides as opposed to the other ones. So before I start doing the constructions, are we okay so far with the vocabulary? I know I went a little quick on them. There's still a few more that you need to go back and review. If you need me to, just remind me tomorrow and I can email you guys all the vocabulary words one more time, okay? So make sure that if that's what's something that you need, just let me know and I can email that to you. But as we're going through this, try to see if you remember how to do this or if you can take some notes. So we are going to construct a copy. So what do I mean by that? Well, I'm going to take this angle that I have, this 60 degrees, right here. I'll put it in red. And I'm going to make an exact copy of it using our tools that we've been using since the beginning. So what we want to do, like always, you always want to begin with a straight line. I'll use this. Let me put arrows in it so I can identify it as a straight line. And then I'll put it in a different color. I'll put it in blue. So here is a copy that I'm going to. I love how I said blue and then I put yellow. It's going to be blue. Let me change that so it pops out. Blue. There you go. And I'm going to copy this angle right into this. So I'm basically going to do this. That's what I'm going to end up doing. The question to that is, well, how do you do that using the tools that we've used? Well, put your compass right at the beginning of your vertex and then open it up It doesn't matter the amount, just remember that you have to open it up. And the best thing to do with this is going to be just create a half a circle or an arc to this to make it easier for you. And let me make an arc there, and then I'm gonna make an arc down there. If I can get it to, nope, it's not what I wanted. Put it at the beginning, and where did I extend it? And then there you go. So make sure you make an arc that passes through both of these two. Okay, and you're gonna do the exact same thing here. You are going to then take it and you are going to label. You're going to label a point on your new line. It doesn't matter where you put it because it's just a copy of the same angle. So I'll just put it here and we'll call this point A. And you're going to take your compass and you're going to put it at A, and then you're going to create that same arc that you did before, where you're going to make a nice big arc, half a circle if you wanted to, or full circle. And then what you want to do, because you want to make sure that you have the same angle that you have here. If you can follow along really quick, I'll do it with this. What you want to look at is this part right here. If you can copy this, we'll call it a triangle from there to there. If you can copy this exact same triangle and you can put it into this new line, you basically have already created your copy of an angle. So you're going to take your new length using this compass again, and you're going to measure it from there. Make sure it hits it right at the vertices. That's the hardest part about this. Okay, and let me rotate it. And what you want to do, again, you want to make sure it hits that intersection there. And there it is. As you can see, it hits it. So we'll change the color so that you can see it. And there it is. Again, if you wanted to do a full circle, as long as you know what you're talking about and how you're copying it. So there it is. We're going to go from this new intersection. We'll call this new intersection point B, yeah? We'll call it point B. And you're just going to create an arc again. That new intersection that you see here, we'll call that one C. We'll call it point C. And now all I have to do is create a line or a ray that begins from A and it passes through C. And if you notice, this will be an exact copy of the one that we just did, 60 degrees. Any questions with this so far? Any questions? Alright, I'm going to continue. So let's go on to the next one. The next one says construct a bisector. So what I want to do now is I want to be able to create a ray that's going to cut this right in half. That's what I'm trying to say. Remember the definition of having a ray? We just went over it ourselves. We're going to take our compass again. This time we're going to put it at the vertex of both of the rays, and you're going to extend it an X amount. Remember, the amount, the length of it doesn't really matter. What we care about is to be able to see that nice arc, where that arc's going to hit here, and it's going to then hit up here as well. As you can see, this time I'm not actually doing a full circle or a full circle or a half circle. So let me move this really quick. I made that extra line for no reason. So now, sorry, I was trying to record and then this thing stopped. So having done that, it gives us two new points. We'll call this one point A and we'll call this one point B. And what we want to do is we want to be able to, with the same distance, go from A and then create an arc. We'll make it green this time. and we're going to create an arc here. And then you're going to go that same distance to B, and we'll put a different color. We'll put this color. And we are then going to go ahead and create the arcs. The intersection of these two new arcs we'll call, let's say, C, and we'll call the vertices X. So in order for me to bisect this, all I need to do is create a ray, okay, that starts at X and passes through C. And when we do that, as you can see, it basically splits, or it bisects this angle right in half. Okay, let me go back to the chat room, see if anybody has any questions. Does anybody have any questions with this? Okay, I'm going to go ahead and move on. Alright, so this is something that I saw last year on the final. It talked about how to add two small line segments. What I'm basically saying is the following. Have a line, and let me go ahead and create this new line. And you're going to make a copy of the two smaller lines that you have. We'll make it green. Here's this new line, and what you're going to take is you're going to take this small piece that you see here, you're going to put in this new line, and then you're going to take the second piece and then you're going to add it to it. So in order for us to do that, you have to be able to label everything. So I'm going to label this as A, B. Remember, these are line segments, they're not rays. It's line segments because they do have a beginning and they do have an ending. We'll call this one D, and we'll call this one, we'll call this one C, and then we'll call this one D. And it does have a beginning and it does have an ending. So we're going to use the tool that we've been using, and we're going to do the exact same thing. We're going to make a copy of it by extending it that length, and then we're going to move it to the new one. Now, how do I know where to begin? Just like I said before, it doesn't matter where you begin in this line as long as you know that it's a small piece that you're looking at. So we'll label this one to be A, and that's where I'm going to start. So the new arc that's going to intersect, we'll call this one little l, line little l. So the new arc that we are going to create, and little l, is going to give you the intersection, which will create B. Now, what you want to do is you're going to take your compass, you're going to put it at C, you're going to extend it, okay, until you find the length for CD. I'll change it into a different color, and what you want to do now is you're going to take this without moving the compass or the length of the compass and begin at B and then make a new arc. So now what you have is C is up here, and then you have D. What we want to do though is we want to take the length of A, D, and then create it into this new line. So let me see really quickly, see if this will work for us. I'm going to make a line, so I need arrows, make it big. I'll change the color of the line this time. There it is. Oh no. And I'm going to take my compass and I'm going to try to extend it all the way, but as you can see, no matter what I do, it's not going to reach there, and I don't think I can make this any bigger than it already is. It just helps me move it. So let's pretend that I do have a compass that fits, and we'll call this one A, and then we'll call this one D. As you go through this, you got to remember though, because you are making a copy of this, this is the original that you have. So you have to make sure that you label everything. Now, because this is the first copy, we're going to label this to be A prime, B prime, C prime, and then D prime. And this is the second copy that we have. So we're going to label this to be A double prime and then D double prime, giving us a total length, okay? So any questions so far with this before I move on to the next one? Well, we have let me go ahead and answer that question. Will we have to use the compass on the final? No, you're not gonna need to use the compass in the final. It's gonna be actually multiple choice. That's the great thing about that it will be multiple choice. And then because it is multiple choice, that means that all of these steps that I just went through, you have to know. You have to know what they are. Okay? So if the question can be taking a look at the following line segments, what will be the first step that you would need to do to be able to make a copy of it? And then you would have to be able to address this step here that I'm circling with the mouse. Okay? So please make sure that you understand that. Let me go back to the chat room. Let's see if we have any other questions. Any questions? Any other questions before I move on? Are we good so far? Okay, good. Thank you. I got a couple of you that answer that. Alright. So let me move on. Construct a line segment perpendicular to this. So remember what the word perpendicular means, right? You're going to create a new line and it's going to pass through this point. Let me move this really quick. It's going to actually pass through this, and in passing through this new point, what's going to end up happening is that it's going to create 90 degrees. Remember that, right? How do we do that? Well, what you need to remember is that you need to let this point, we'll call this point A. We're going to let A be the center of a circle. Okay? So we're going to let it be the center of a circle. That way, when I create an arc up here and an arc down here, when I meet these three, when I see the intersection of those three, it's going to cut right through that point. The question is, how do we go ahead and do that? Again, you're going to have to use your compass. And you are going to then create a circle, or a half length if you want to call it, or a radius if you want, that has this form. So I'm going to create a circle just so that you can see. When I do that, it gives me two new points. We'll label this point to be B, and we'll label this point to be C. What I want to do is I want to be able to just bisect or cut this line segment, because from A to B is a line segment. And what I want to do with it is I'm going to start at B, and I'm going to make it a little bigger, like in between A and C, and then I'm going to create an arc up here. And then I'm going to create an arc below the circle without moving the distance. It's very important that you understand, again, you're not moving the distance. Then you're also going to do the same arc without moving the compass. I'll put it in a different color. That way you can see. And then you will see the intersections above and then the intersections below. And in doing so, you will see that all of them crisscross. It does look like a little hot mess. I know, I get it. But remember, what we want to do is we want to be able to look at the blue and purple intersection, and then the blue and purple intersection below. And in doing so, you see that this new line, this red line, intersects that that point that was given to us at the beginning. Okay? Any questions with this? Constructing a line segment perpendicular to the given point. Okay, so I'm hoping that everything's good so far. I'm going to continue. This time, the line segment has to pass through this point, and it has to hit, we'll call this one little l, line little l, okay, so that we are familiar with what we are doing. You're going to then take the compass, and you are going to put it at the point that is outside of this line, and you're going to then stretch your compass so that it passes line little l, and then you're going to create arcs. And in doing so, when you do that, it gives you two new points. We'll call this point A, and we'll call this point B. And then again, you are going to then bisect. You're going to bisect what you know. So how do we bisect something? Well, we first have to figure out where the middle is. Somewhere around here is going to be the middle, and you are going to then extend it a little bit more than the middle, and you are then going to go ahead and create your arcs. So let me create an arc up here, and then I'm going to create an arc down here from A. Okay? Now, you're going to do the exact same thing from B without moving the length of the compass. Make sure it stays the same. It has to stay the same, or else it's not going to work. You're going to get something completely different. And you do an arc on the top, and then you do an arc on the bottom. And then we're just going to connect these two lines now. I'll use this one. That's where they crisscross, and it's going to go through there. And let me go ahead and move this a little bit, and let's pretend that I did it correctly with the compass, the beginning, and it intersects that point there. Okay? Super simple. It's not that hard. You just have to remember that in order for you to do this, you have to extend from that given point, extend more than the line that's given to you, so that you can find out where A is and where B is, and then find that that line segment that bisects these two lines. That's all you have to do, because if you do that, then it's going to automatically hit the point that's outside of the line. Any questions before I move on to the next? So we first have to make the green dot. Yes, that's correct. You first have to make that green dot. Once you get that green dot going, everything else will just follow, because you're just going to end up with A, B, and then making sure that we have all of these intersections. Okay, so far so good. Now remember, this unit itself talks a lot about vocabulary, and it talks about the distance formula, it talks about the midpoint. So let me go ahead and jump into the next one. So that says that we're looking for the distance between 2 points. So remember, the distance formula says is the square root of x2 minus x1 square plus y2 minus y1 square. Where does all this information come? Well, it comes from figuring out that this is your point 1, and point 1 is located at negative 2 comma 0, and it comes from understanding that this is your second point, and we'll call this P2, and P2 is located at 3 comma negative 2. Now that we understand where those points come from, we have to learn to label them. Every point has an X and a Y to it. You just got to know where they come from. So for example, this negative 2 comes from, it's an X, we know that, but it also comes from point 1, so we label it X1. The 0 comes from, it's a Y value, and it comes from point 1. And we do the same thing, X2, Y2, and then we just learn to substitute everything into the formula that's given to us. So I'm going to go ahead and do that now. Parentheses square plus parentheses square, and then we're going to go ahead and substitute what we know. Okay, so what I know is that x2 is 3, and then I'm going to subtract this one right here, which is negative 2. Now please notice that I put a parentheses here, and I put parentheses here for a reason, is because I know that a negative times a negative will be a positive, and then I'm going to be able to change this afterwards. Okay, so y2 is negative 2 minus, right, minus, because that's part of the formula, 0. So now I have d is equal to the square root of a negative times a negative gives you a positive. So now I have 3 plus 2 square plus negative 2 square. So now we have d is equal to the square root of 5 square plus 4 square, which gives me the square root of 25. That should be 2 square. because a negative times a negative, so plus 4. So now I have D is equal to the square root of 29. Now, we're going to leave it like that because I believe that the final will have it in a radical form. We know that 29 is a prime number, so we really don't have to simplify any further. However, sometimes you might need to simplify, so make sure that you're aware of that, okay? So any questions with this question that we just did? Point 1 will always be the first one. So yeah, try to remember as point 1 to be the one that you encounter starting from left to right. So wherever that point 1 is, let me go back to the screen. So if you go from left to right, wherever that first point is located, that will always be your P1. Okay? Always. Try to remember that. And then when you keep on going, you will find where your P2 is located. And then everybody, I hope, that understands how to find a point. And then all you have to do is label it accordingly. Remember, where does that point come from? You should always remember that. Or where does it come from? If you know where it comes from, then you can label it. Is it from the first point? So then you're going to label it x1, y1. Or is it going to be from the second point where you're labeled it x2, y2? Okay? So please be aware of where it's coming from. That way it makes sense how you're going to put it into the formula. And remember the formula too. The final, remember you're going to be facing the east wall of the classroom. And then that wall there, you're always going to see the distance formula. I'm not going to take it down, okay? So you don't have to worry about that. So having said that, let me go ahead and ask the famous question. Do we have any other questions besides what is radical form? Radical form, remember, is this where like it has the square root. So it's this part right here. It's the square root of 29 that we're not going to be able to simplify. Okay, any other questions? Okay, so since there is no other questions, I'm going to continue with the next one, the next example. The next example says find the midpoint. Okay, so with the distance formula, you know that you're going to need a formula. For the midpoint, you're going to need the formula as well. But this time, remember that the formula for the midpoint is a lot easier. It says you take x1 plus x2, and then you divide it by 2. And then you do the same thing for the values of y. So you go y1 plus y2, and then you divide it by 2. That's all you have to do. And then you're going to leave it as a as an order pair, or as a coordinate on the coordinate plane here. So I'm going to go ahead, and again, I'm going to go from left to right, and I'm going to see where is that first point. This red one here, we're going to call it P1, and I'm going to continue. And this one down here, I'm going to call it my P2. My P1 is located at -3, comma, -1. And my P2 is located at, as you can see, 2, comma, -5. And now I'm going to go through it again. I have to know where they belong. So I'm going to label this to be x1, y1, because they belong with point 1. I'm going to label this to be x2, y2, because they belong, again, they belong with the point 2. Now I'm just going to substitute everything that I know into the formula. So it says x1, which is -3, and I'm going to add, it says plus my x2, which will be 2, and then I'm going to divide that by 2, comma, and then I'm going to take y1, which in this case is -1, and then I'm going to add my y2, which is -5, and then I'm going to divide by 2. And then I'm just going to simplify after that. Remember, every time that you do this, try to simplify. Most of the answers, I believe, that on the final are going to be in simple form. So please make sure that you're aware of that. So -3 plus 2 gives you -1. You divide that by 2. So it's located, the x value for it is located at -1/2, or a half, I should say. And then you have a positive and a negative, still makes it a negative. So if I owe you 1 and I owe you 5, I owe you 6, and then I'm going to divide that by 2. So I'm just going to simplify. So now, where is this point located? This point is located at -1/2, comma, -3. close parentheses. So we go negative a half. If this right here is negative 1, negative a half is between that, and it's located right there. Here is your midpoint of the line segment. Okay? Any questions with this one? I'm going to ask you again, is there any questions with this problem? It's super easy once you understand where the points come from and how to substitute it into the equation. So, one last time, is there any other questions with this? May I move on? Yes, wait, okay. Yes, what would you like to ask? Is there any questions? Can there be a decimal? Okay, so there it is. Can there be a decimal? The answer to that is yes. Yes, it can. But when we talk about coordinate planes here, as you see here, it's a lot better if we leave it as a fractional form and kind of estimate where a half might be. Or let's say, for example, it's at 3/4. Remember, 3/4 is between 0 and 1. So it'll be somewhere, if this is the line, it'll be somewhere around here, right? Because somewhere around here will be half. So 3/4 will be a little bit more than half, but a little bit less than 1. So yes, you will have some decimals sometimes. Not all the times, though. I'm going to be quite honest with you. And if I were you, I'll try to leave it as a fractional form rather than think about it as a decimal. Okay? Is there any other questions? Did that answer your question by any chance, Joshua? Okay, so let's see. Let's continue. The next one is the missing side. Well, what do we know about this? And I give you some information here. That this is a right angle. If it's a right angle, we can use the theorem a squared plus b squared is equal to c squared. And that's great for us because we can go ahead and use it. What do we know? Well, this right here, this side will be our a, and this is our b, and this is our c. So what I'm really looking for is going to be something unique. This one here is something that you should be able to do. I just put it here as for you to look at and to be aware. Yes, it's something that we cover through. It is something that we went by, but we did it together, and we did it in 7th grade as well. So this is something that you should feel familiar with this, okay? I'm not going to spend some time doing this. I honestly feel that you know how to substitute and you know how to simplify. So that's something that you have to remember how to do, okay? This one here, I'm going to go into the length, as you can see here. But before we go, it says, let me go back to the screen. There you go. So we're taking a line segment. I'm telling you. I want to know exactly what I to j is. That's the big question mark. In order for us to figure this out, we have to first know what x is. Like always. That's the big question. What is x? So we have to remember something about this. I'm telling you. Let me erase this really quick. I'm telling you that you're going to take this small piece and then you're going to add it to the second small piece. And in doing so, you're going to get the entire length from j to k. From I to k, sorry. So this is what you're doing. I'm going to write it up here. You're going to take a small piece of I, j, and you're going to add it to jk, which will then give you I, k. Small piece plus a small piece will give you the big piece, okay? So all we want to do now is be able to substitute what we know. So I'm going to substitute this into here. I'm going to substitute this into here. And then I'm going to substitute the total, which is my k, as you can see here. So now what we want to do is just put it all together and then just simplify. So we're going to go 2x plus 1 plus x plus 3. That is equal to 13, and then I'm going to combine things that are alike. So for example, 2x and x will give me 3x, and then I'm going to combine 3 plus plus 1, which will give me plus 4, which will be equal to 13. And then I do the subtraction property of equality. That simplifies, and then I'm going to have 3x is equal to, that's going to be 9. And then you do the division property of equality, and then you get that x is equal to 3. So now, we know what x is. What do we have to do? Well, remember, we always have to go back to what the question is. What is the question asking you? I want to know the length of ij. So, the length of ij is 2x plus 1. So all I have to do now is substitute x. So I get 2 times 3 plus 1. So I get is equal to 6 plus 1, which is equal to 7. So this here is 7 units. I could also ask you, okay, well, what is the line segment JK? So remember, you substitute it in, and then you'll be able to get it. So it should be 6, right? Because it's 3 plus 3, give you 6 units. 7 plus 6 will give you the 13 units that we were looking for. And I'm calling it units because I don't know if it's in inches, I don't know if it's in meters, in feet, in miles. We're just going to call it units, okay? So, any questions with this before I move on to the next question? Okay, there's no questions. Yes, I see somebody raise a hand. So remember, we can name it that way. And here's the fourth way to name this. We can name it the opposite starting from E, D, C. One thing that you should notice, though, is because I am speaking of this angle D, D always has to be in the middle. Okay? It has to be in the middle. This one's super easy. It's just learning how to name it. I'm going to move on to the next question. The next question, this is a hard one. This is a hard one because of what it's asking. It's asking for you to find what YJK is. So you want to know what this angle is. So this little angle right here is what you want to know. We'll put a question mark there so that you can see. Now, what you should know is that if you have a small angle and you have a second small angle, so you have angle 1 plus angle 2, it will give you the entire angle 3. So from here, let me erase this really quick. So from here to here, which will be KJI, that will be considered angle 3. So let's look at the information that's being given to us so that we can identify what we have. So I, J, Y is this little piece here, and that is going to be 25 degrees. Then it says, and I'll put it in red, I, J, K. So the entire thing, this one here, is 115 degrees. So what we want to know is this piece here, which we're going to label X. So now I have X plus 25. X plus 25 degrees is equal to 115 degrees. And from here, we just do the subtraction property of equality, where we get to subtract 25 from both sides. Right? So we subtract 25 from both sides. That simplifies, and then we're left with X that is equal to 90 degrees. Okay, that is equal to 90 degrees. And it's super simple. So 90 degrees plus 25 will give us that 115. And that's what I wanted to know. What is KJY? Any questions with this before I move on to the next example? Okay, there's no questions. I'll continue. Like I said, these are mostly review than anything else. The ones for next week are going to be intense. So what type of angles do we have here? If they're opposite from one another, they are called vertical angles, right? These are vertical to one another. No matter how many lines I could put across, I could even add an extra one here. It doesn't really matter. You will still see these two will always be vertical to one another. The next one says, what type of angles do we have? Well, let's try to picture this. Let's forget about this one here. This line does not help us, right? So what do we have? Well, we have, let's call this line little l, and we'll call this one little n. Okay, so we have little l and little n that are, remember what the two little signs mean here, they are parallel to one another. If they are parallel, and we'll call this one little t is the transversal. So then we look at angle B and angle A to be alternate interior angles. If we have the same scenario here where we're going to take away one of these lines, we'll take away this one because it doesn't help us, it doesn't give us any information. But we notice that we have B and we have A, they're on the same side. One is in the inside, one is in the outside. We have corresponding angles, right? And the last one here that we see, we have adjacent angles to one another. Remember, these are vocabulary words that you should feel familiar with. I'm just going over them so that you understand that yes, they are going to be a part of the final, and I will be putting algebra behind them so that you understand how to do them. These are called alternate exterior. These are called alternate exterior angles. And here comes all the fun part now. Now that you understand what they are, we can then go ahead. I'm going to move this. It says find for x. We're going to be able to see that we have a set of parallel lines that's cut by a transversal, right? So we'll give them letters, little l, little n, and then little m. A little m is a transversal to l, little l and little m. We know that we have alternate exterior angles. Alternate exterior angles allows you to set them equal to each other because they are the same. And once I set them equal to each other, I see that all I need to do is do the division property of equality, and I get that x turns out to be 13. Super simple. It's not that hard. Any questions so far with these? Alright. No questions so far. Let's look at the next one. We have corresponding angles here. We know that corresponding angles are basically congruent to one another. So we know that we have an interior, we have an exterior, and just like we did before, we're gonna forget about this line here. It doesn't help us. It's more of a distraction than anything else. So we're just gonna get rid of it. And well, what do we know about corresponding angles? They are congruent. So we have 2x that is equal to 96. And then I use the division property of equality, and I get that x is equal to, let's see, 44. Okay? Super easy. It's not that hard. Again, you still have to be able to understand 44. No, sorry, 48. Sorry. 48. You still have to be able to look at what I give you and be able to analyze. Okay? Be able to analyze. Again, this one's asking for figure out what x is. I'm going to make this a little bit bigger so we have a little more room. We just want to know what x is. You should remember, though, that what we have here is a straight line. What do we know about a straight line? Just like the example that I gave you before, they are supplementary to one another, right? We'll call this one angle 1, angle 2, and we said that if we have a straight line, we add them together, we equal them to 180, so they're supplementary. So I'm going to go 3x plus 16 is plus 95 is equal to 180. And then all we want to do with this is be able to combine like terms. So it'll be 95 plus 16, which will give us 111. So we have 3x plus 111 that is equal to 180. And then you use the subtraction property of equality. So you subtract 111. That simplifies, and you're left with 3x that is equal to 69. And then you use the division property of equality, and then You divide both sides by 3, and then you get that x is equal to 13. Okay? 13. Oh my gosh, I'm off today. Sorry, guys. 23. Sorry, it's 23. Okay, so remember, when you see them this way, that means that they are supplementary to one another. Supplementary to one another. Let me go back to the chat room. Is there any questions with that? Okay, perfect. Let's continue with the last one here. These are alternate exterior angles. With alternate exterior angles, you just set them equal to each other. So you use the subtraction property of equality, and you get that 6x is equal to 144, and then you are going to use the division property of equality and then divide both sides by 6. So you're going to divide by 6, and you get that x is equal to 24. Okay? Let's see. This is a good one here. Again, I'm looking to see if we know what x is, or I want to know what x is, right? I'm going to move it so that I have a little more room. Remember, just like we talked in class, a full circle itself always turns out to be 360 degrees. So how do I figure out what these two are? Okay, well, I'm just going to do the entire circle. So I'm going to take 299 plus x minus 121 plus x minus 116, that is equal to 360, because that's something that we know. So I'm going to combine things that are alike. So I'm going to add these three because they're just numbers, and then I'm going to combine these two because they're just variables. So I end up with 2x that is equal to, let me see, 299 minus 121 minus 116, that is equal to 62. So it'll be plus 62, that is equal to 360. And this is a two-step equation where we use the subtraction property of equality, right? And then we end up with 2x is equal to 2x, that is equal to 360 minus 62, 298. And then 298, you're going to have the division property of equality, where you're going to get to divide both sides by 2. So 298 divided by 2 will give you 149 degrees. So what is x? X is 149. So when you substitute it in here, it will make sense that that x itself will be 149. Any questions so far? Okay, so far we're okay. It seems like you're remembering all this, which is really good for us. And I believe that was the last example that we were going to have for tonight. Let me go back to the chat room.